I hope you understand what is conductor, what is coil, what is turn, and what is full pitch, and how to find out the uh, pole pitch, and what is coil span. So let us take one example. For 24 slot 4 pole machine, we have to design the winding. But before going further, we should understand how exactly pole is forming. That means, let us say suppose these are the number of slots. Slot number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So likewise, so let us say in this case, pole pitch is equal to 24 by 6, which is equal to 24 by 4, which is equal to 6 slots. That means this is slot 1, 2, 3, 4, 5, 6. So this is our north pole. 7, 8, 9, 10, 11 and 12 and so on, as there are 24 number of slots, but we will consider only these two, and this one is south pole. So how exactly these two means this pole and this pole is acting as a south and north. So there is one concept that you have to understand. Whenever we are placing winding, let us say one coil is placed here in first slot, means R phase winding, it is placed in first slot, and second coil side it is placed in seventh slot, like this. So to form north pole, all the conductors, likewise I am going to place for, means this is another coil for R phase. Let us say suppose I will show here with black pen, or let us assume with red pen itself. This is for B phase and this one is for Y phase. So all the conductors, means all the coil side in case of north pole should carry the current in upward direction, then it will act as a north pole only. So this is the condition, means for all the conductors or the coil side which is under this north pole should carry the current in upward direction. This is the assumption, and accordingly we have to do the connection. And see, as the current, means suppose connection is given here and likewise current is flowing here, during this, means in coil side 2 the current is flowing in downward. So likewise this is another coil of R phase in which current should flow in downward. Similarly for this is B phase and this one is Y phase. So under south pole the current in coil side it should flow in downward direction. So how to identify north and south? See, all the coil sides should carry the current in upward direction, and during in case of north and in case of south all the coil sides should carry the current in downward direction. But before going further, let us understand how it is going to execute. That means, let us say, means how to place the winding, how to place coil, means as I said, each coil is having coil side 1 and 2. This is coil side 1 and this one is coil side 2. So if coil side 1 is carrying current in upward direction normally, then coil side 2 it will carry current in downward. Similarly, and in reverse way, we can consider that if coil side 2 is carrying the current in upward direction, then coil side 1 it will carry the current in downward direction. And for understanding which one is coil side 1 and coil side 2, in further practice what we will do, we will show coil side 1 with straight line and coil side 2 with dotted line. Means while drawing the diagram in AutoCAD we will use this convention. Now let us check the effect of this phase sequence on this. So let us draw the first waveform. So this is R phase. The 120 degree lagging to this is nothing but the Y phase, and 240 degree lagging to this is nothing but the B phase. So this is nothing but the R, Y and B. Now let us take one time instant at which, let us say, suppose this is the time instant. So you may observe here, at this time instant R and Y both are positive but B is negative. So what is the effect of this? Let us say, suppose this is R phase coil, and this one is B phase, and again this one is Y phase. Try to understand, because this is very important to know about three-phase winding. Okay, so at this time instant, as I said, R phase is positive. That means, let us say if I'm going to give the supply here, that is R start, then current will start flowing like this. So in coil side 1, current is flowing in upward, and coil side 2, current is flowing in downward direction. Then, as I said, this is R phase, this one is Y phase. As I said here, in this case, at this instant, Y is also positive. That means if I'm going to connect the supply here, the current in coil side 1, it will flow in upward direction in coil side 1, and in case of coil side 2, it is flowing in downward. But at the same instant, if we are talking about the B phase, it is negative. That means if I'm going to connect here, the direction of current in coil side 1, it will be in downward, as here it is negative, and in coil side 2, it will be in upward. So you may observe here, at this instant, in coil side 1 of R phase, current is flowing upward. In coil side 1 of Y phase, current is flowing in upward, but in coil side 1 of the B phase, the current is flowing downward. And it is happening in every time instant, means it may be in case of B phase, it may be in case of R phase. If we consider this time instant, in this case R and B, it is negative and Y is positive. That means in case of Y phase, in coil side 1, current is flowing in upward, but R and B, in coil side 1, current is flowing in downward. But with respect to this time instant, we will draw the diagram. Let us say, as I said, this is first slot, second slot, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th. Okay, so for R phase, I'm going to place the coil in first slot, means coil side 1, it will be in first slot, and coil side 2, it will be in 7th slot, like this. Then there's another coil of R phase, I'm going to place it in coil side 2, and the second coil side, it will be in slot number 8, like this. Then this will be the B phase, see, and this is Y phase. We are going to keep 2 slot empty, and then we will place the Y phase. It is also having some reason that we'll see later, but just consider, as I said, this is coil side 1 of R phase. At this instant, the current in coil side 1, it is flowing in upward, so I will mark here, it is flowing in upward. Then I will place Y phase winding. It will be from 5th to 11th and 6th to 12th. So like this, I will place the coil. Then in Y coil also, current in coil side 1, it is flowing in upward, and current in coil side 2, it is flowing in downward. Same in case of R, here it is in downward. Now if, means while placing the B phase winding, if I am going to place coil side 1 here, then what will happen? The current will flow in downward direction. So just keep in mind, in this case we have to place coil side 2 of the B phase in this slot so that the current will flow in upward like this, and the coil side 1 it will be in this slot so that current will flow in downward. So accordingly it will form north and south pole. I hope you understand why to place RBY, and in that case we have to place for R phase coil side 1 in this slot, for Y phase coil side 1, but for B phase we have to place the coil side 2 in this slot. I hope you understand this. Now let us find out the question of the second question, then that is nothing but the why to place R, B and Y. Welcome back. Now see, I hope you understand why to place the winding in that fashion, like R phase, Y phase and B phase. Now there is a second question, why the sequence is R, B, Y, why not R, Y, B? I hope you are aware about this, that if we consider this is one motor and this one is one pole, so this is one pole pitch, and whenever we are placing one coil in first slot and another coil side in one pole pitch away, then the phase difference between these two coil side, means EMF induced in these two coil side, it is 180 degree phase shifted. Means let us say suppose E is nothing but the EMF induced in this coil side and another E is nothing but the EMF induced in this coil side. So if I am going to draw the plot, means phasor diagram for this, then I will note it at E and E dash, then it will be equal in magnitude and opposite in direction. That means this is the coil, so if we consider this is EMF E and this one is E dash, so it is opposite in direction. If this is in upward, this is in downward, that means it is 180 degree phase shifted, E and E dash. So in short we can say that if this is the north pole, means one pole is responsible to produce 180 degree of electrical. So if we consider, suppose this is one pole and slot number 1, 2, 3, 4, 5 and 6, and this one is 7th. So this is one pole, this one is north pole. So if I am going to place one coil side in first slot and another in 7th slot, then the phase shift between these adjacent coil side, it will be 180. In short, one pole is responsible to produce 180 degree of electrical. Now, so if 6 slot is responsible to produce 180 degree of electrical, then one slot it will be responsible to produce 180 by 6, that means 30 degree of electrical in case of 24 slot motor or alternator. Now if we consider, let us say first slot, slot number 4, this one is 5, 6, 7, 8, like this. So as I said, each slot it is responsible to produce 30 degree of electrical. That means if I am going to place one coil side in slot number 1 and another coil side in slot number 2, so let us say EMF induced in coil side 1 is E and EMF induced in coil side 2 is also E. Then if these two coil sides are one slot away from each other, that means if this is EMF E, the phase difference between these two is 30 degree. 30 degree. That means if I am going to place another conductor in, let us say 5th slot, and if we compare the phase difference between this coil side and this coil side, then as it is 4 slot away from each other, then EMF induced in both the coil side is E, but the phase difference is 4 into 30, which is equal to 120 degree. So I hope you understand. If we consider in this case, if these are the 6 slot, the 6 slots means if I'm going to place one conductor or one coil side in first slot and another in 7th slot, then the phase shift between EMF in these two coil side, it is equal to 180. That means this is one pole which is responsible to produce 180 degree of electrical. So what is the effect of this on our winding diagram? Let us say there are 3 phases, like this one is R phase, this is Y phase, and this one is B phase. Okay, it should be identical one because we have to draw for balance. Just try to understand. The phase difference between these is 120, 120 and 120. Now let us say slot number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 1, 2, 3, 4, 6, 7, 8, 9, 10. We have 3 coils. This is R phase, this one is B phase, and this one is Y phase. Now at that particular instant, current in R phase is upward, means coil side 1 in R phase of upward, coil side 2 it will be downward. For Y phase it is upward, here it is downward, and for B phase here it is downward and here it is upward. Now if I'm going to place the first coil side of R phase over here and the second coil, means this is first coil like this, first slot to 7th like this, then this is second coil of R phase. In similar way I'm going to place like this. Now I have to place the coil side of Y phase. Then where to place? If I'm going to place in this third slot, then the phase difference between first and third, it will be 30 plus 30, it is 60. So it is not accepted because the phase difference between R phase and Y phase, it will be 120. So we have to maintain that phase difference. So where to place the winding of Y phase? See here, first, second, third and fourth. So if we consider this 4 slot, the 4 into 30, it will be 120. So if I'm going to place the coil side 1 of Y phase in 5th slot, then the phase difference will be maintained as 120 degree. Similarly, the second coil of Y phase, it should be placed in 6th slot, so that the phase difference between this 1, 2, 3, 4, that means 120 is maintained. What about B phase? Let us say, suppose this is first, second, third, fourth, fifth, sixth, 7th, 8. So 8 into 30, which is equal to 240, and you know that the phase difference between R and B phase is equal to 240. That means we have to place the coil side 1 of B phase, which is equal to 8 slot away. That means here we have to place the coil side 1 of the B phase, and the coil side 2 will be placed further, and you may observe here the direction of current in coil side 1, it will be in downward in the B phase. So, and we have to place it like this, so that the phase difference between this, it will be maintained 240. And similarly, as I said, the coil side 2 is placed here like this, in which current is flowing upward. So this will act as a north pole and this will act as a south pole as the current is flowing in downward. I hope you understand why to place R, B and Y in this way. So in the further session, if you are having any doubt, you may ask me. I can clarify your doubt and explain this concept in brief. I think this is enough to understand why to place the winding in this fashion, like this: R, B and Y. So this is the answer for the second question. Now with this knowledge we'll start to build up this diagram. So here also you observe that this one is R phase winding, this one is B phase, coil side 2 of B phase, and this is Y phase. So in details we'll see how to draw this one by one. I will just revise the quickly what you have to understand and what you have to remember. So to form north pole, the current in each slot, it should be in upward like this. So if this is north pole, the current should be in upward direction, and for south pole the current should be in downward direction itself, so that it will act as a south and this will act as a north. One more thing, at particular time instant, if we consider R phase, if current in coil side 1 it is flowing in upward, the coil side 2 it will be in downward. For B phase it is opposite to that of R phase, that is in coil side 1 current is flowing downward, coil side 2 it will be in upward, and for Y phase it will be like this. So this is at particular time instant. At different time instant it may get changed, and accordingly to form north pole we have to place here coil side 1, this will be for Y phase coil side 1, and this will be for B phase, we have to place the coil side 2. I hope you understand. That means we have to place R, B and then Y. So with this we'll see how to draw the diagram. We'll stop here. Thank you so much.